Hi everyone. So next topic is step function. So regression with step functions. So remember that what is the step functions? Regression with step functions. So step function is just a piecewise the constant function. So in this case, the C not x is the indicator function of x is less than c1, and c1x is the indicator function of x is between c1 and c2, and so on. So here we use the k plus 1, the step functions, to fit y. So y is equal to this function. So beta naught to beta k are estimated by least square, so it's not difficult. But the deciding the knot points are really not easy problem. Okay, so remember that we have defined time index. This is from 1871 to 1970. So 100 time points, and the Nile River data is so this is the data. So we want to fit the step function on this. So you can see probably the level is higher in the beginning and the maybe almost stable from 1900 to 1970. So to use the step function, basically we can use the cut function in R. So cut time 4. So then we can see this. So basically, this gives the 4 functions. So basically, first one is indicator function for first 25 observations. So this is the first category. And the second 25 observations are second category. And the another 25, so 51 to 75th observations. Then finally, we have last 25 observations. So basically, these have the 4 categories. So this cut function that makes that define this the 4 factors on this variable time. If you type cut of time 4, you can see the range and the number of observations. So basically, we equally cut the entire range into 4. Since the choosing knot point is difficult, so just it automatically cut off, automatically define cutoff points to equally divide this time into 4 parts. Then we can fit regression line as usual. So linear regression Nile on cut of time 2. So originally we have this plot. So if you want to overlay the fitted curve, then you can see this. So we have the higher level here and lower level here. Oh, here we have the time 2, so we have only 2 sections. So we divide at the 1920.5. So before 1920 and after 1920, we have different levels. So next, we want to have more knot points, and we want to see what is the optimal model. So we want to try from 1 piece to 10 piece. If we fit the no knot point, then just we fit the flat line. Then if we have the 2 pieces, then we have this. But if we have 3 pieces, we have something like steps. So we want to do this automatically. So at first we define object ls to store all result. So list of step function regressions. And also we want to calculate AIC for each model. So we prepare vector of 10 numbers. So list of AICs of 10 different models. So now that we define at first the first degree one, so we just fit null on intercept. So we cannot use cut function because cut time 1 has some error. So just we separate the first one. And of course you can calculate AIC of this model. So AIC of LS1. AIC is actually the 1313. Okay, so now that we want to define step function from 2 to 10, so I is equal to 2 to 10. Oh. And ith object of ls object is lm nil on cut time with I different step functions, and we also save AIC of this model. Then we do this for I is equal to 2 to 10. So now that you can see, for example, summary of LS2 or LS3 or LS4. We have already, we haven't seen it. So summary of LS2, you can get this. So you can see that if we have two pieces, that actually the later period has a significantly lower level than the first period, and actually the difference is negative 129.94. So actually 130 lower in the later period. How about 3? So third one, okay, actually the first term is on average the 1049, and the second term in the middle, we have the 204.8 lower than the first level. And actually the last period is compared to the first period, the 190 lower. So actually it's slightly higher than the second period. And you can go, you can get the same result for higher degree. So now maybe we can see summary, but maybe before that, maybe we want to see what is the optimal, the number of step functions. So we want to make a graph of AICs. So just graph of AICs, and x-axis is the number of step functions, and y-axis is AIC. Then the graph is this. So you can see that if we have one piece that we have already seen AIC is the 1330, and it goes down, and goes down. And if we have 4 pieces, actually it achieves optimal. After that, actually it gets worse. Basically, more functions than AIC penalize the model if the model performance doesn't get better. So actually, it seems that n is equal to 4. 4-step functions is optimal model. So maybe we can plot this from the 2 to 4. So at first plot of time nile, and this is original plot, and we overlay ls2. Fitted value of ls2, so fitted ls2. Then we have this, but if we go beyond 2, 3, and 4, maybe we can try also 5, then we have this. So maybe we should distinguish it by color. So maybe 2 as color 2, and 3 as color 3, 4 as color 4, and 5 as color 5. Then you can see this result. So you can see that this red one is 2 pieces, so it's not really optimal. And the 3 pieces, that we have the green one, and the 4 pieces, this blue one, and the 5 pieces, the light blue one. And you can see that the first, the 1/4 of observations are relatively higher than other observations. And actually, if we use the 4 pieces, it fits well because we have knot point here. So really, the location of knot points are important, and this n is equal to 4 is lucky that we have knot point just here. Okay, so this is the basics of how to fit the step functions in linear regression. Okay, see you then.